Bismillahirrahmanirrahim. In this video, we're going to learn about nodal analysis. The first step is to set reference point. What is a reference point? A reference point is at the point with the most essential nodes. So you need to identify essential nodes first. So what is an essential node? Essential nodes is when you have at least 3 or more branches at a single point, like this. And remember, what is a node? A node is when you have 2 or more branches at a single point. But essential nodes is when you have at least three branches or more at a single point. Okay. So when you found this node, you need to put a reference point. A reference point always gives you the value of 0 volt. Okay. So in case of our example on the right side here, the most branches or essential nodes is at this bottom node. So you can set the reference point here, and you should know that all of this node here is equal to 0 volt. The second step is to name all nodes that you have in the figure. Let's say in our example here, you have 3 more nodes, and this part is actually 1 here. So how you name all these nodes? Maybe you're going to name it as a value or a variable. Variables such as Vx, Vy, V1, V2, and etc. And value, if you have, like in our case here, you have 10 volt. So you have 10 volt, 3 volt, any value. But how do you know that node have this 10 volt or any other value? You can figure out by looking at the voltage source connected to the reference point you just put. So let's say you put this as a VA. And from our rules, we know that higher in polarity should be minus with low in polarity. The higher in polarity is the VA here. The positive side here is the VA, and the negative side is the 0. So higher in polarity minus with low in polarity, VA minus 0, should be equal to the value of this voltage source. In our case, 10 volt. So we have 10 here. Then VA should be equal to 10. Then you don't need to put the name as a VA, but you can put it as a value. So that's why we have here as a 10. Right, step number 3. You need to give current direction, and you can name the current. In my case, I always have a horizontal, the current is to the right. So this one maybe I1, and vertical branch with the from top to down. So maybe this is I2. You can name it. So in our case here, maybe we give a name. Just put any direction you like and be fixed with that. So this is I1, I2, I3, and I4. Depends on you. So what is a supernode? Supernode is when you have a voltage source, whether this is a independent voltage source or dependent voltage source. As long as this is a voltage source, and this voltage source is in between 2 unknown, like maybe V1, Vx, or V2, V3, so on. So obviously this is an unknown value, and this is a voltage source. Okay, whether this is a independent or dependent voltage source, and in between 2 voltage nodes, then this is a supernode. There's other condition for supernodes. if you have a voltage source, whether this is independent or independent, and in parallel with something, some branch, maybe a resistor, capacitor, or inductor, and this is in between two unknowns like V1 or V2, then you need to put a wall or a barrier like this. Okay, a temporary enclosure like this. And we call it as a super node. So what should you do if you have a super node in your circuit? You need to apply two rules. One is the KVL at the super node, and the other thing is KCL at the super node. There's two rules, KVL and KCL. So what is KVL at the super node? The easiest way to understand what is KVL at supernode is, let's say we have an example on your left side here, and you know that this higher in polarity should be minus with low in polarity, V1 minus Vx equal to the value. So the value is 5. Then this is your first KVL at supernode equation, V1 minus Vx equal to 5, example just now. And then if we have, what is KCL at supernode? Maybe this example, you have a Ix here, Iy, and maybe this is Iw. So the equation for this KCL is summation of all current entered should be equal to summation of all current leaving. So Ix should be equal to Iy plus Iw. So this is the two equations we have. If you cannot find any supernode, then you can just skip step number 4. Okay. So what should you do? Go to step number 5. Okay, let's see, we have this example. Do we have any supernode? You need to check on the voltage source, not the current source, only the voltage source, and check whether this voltage source is in between what? In between two unknown. So in our example here, we have a voltage source, but this is a 10 volt and this one is a 0 volt. So obviously this is not a supernode. Supernode should be in between two unknown. So in our case here, we don't have any supernode. Before we proceed to step number 5, let's look at your aim. The aim of nodal analysis is to find the unknown nodes. So in our case here, the V1 and V2 is the unknown nodes. So you're going to find these two values, V1 and V2. So what is step number 5? Number 5 is to find or build equation of KCL at the unknown nodes. Let's take KCL at V1. You have this 1 kilo here. If you are unsure, you can redraw your circuit and take up all values. You have 2K here and V2 here. But you need to remember that you copy it correctly. So you have here V1, this direction, V2 and V3. Oh, sorry. This one's supposed to be I, and I. The current, right? So this is I1, I2, and I3. That's why I said you need to copy this correctly. Then build up the equation. Apply Ohm's law. Ohm's law says that I equal to voltage divided by R. So you know that summation of all currents should be equal to current leaving. Current entering this node V1. So current enters only 1. I1, and current living we have 2, I2 plus I3. So what is your KCL? Apply this rule. You have a voltage. So how do you know this? You need to apply passive sign convention. Since I1 direction is from left to right, and entering current here should have a entering current to this passive element of 1 kilo ohms should have a positive polarity, and leaving this 1 kilo ohms should have a negative polarity. So you know that higher in polarity minus with low in polarity, then minus V1 divided by R of 1 kilo ohm here equal to I2. Higher in polarity, which is a plus sign here, the V1, minus with the low in polarity, 0, and divide by 5K. Then plus I3. What is I3? Entering current of 2K here should have a positive here and minus here. So V1 minus V2 divided by 2K. And you simplify this. But here you can multiply by, let's say, 10K. Kilo, you can cross that, and you will have the first equation here. Next, to find KCL at node 2, V2. And what is the equation? Yeah, you can always draw your second. This thing you can multiply by 10K and simplify this. You will get, this is the second equation after you rearrange this. And step number 6 is to find value of interest. You can find using matrices from your calculator or quadratic form, and then you will get your value of interest, which is V1 and V2. The answer is in your slide. There is some small correction on our previous calculation. The first equation was 17V1 minus 5V2. And the second equation will be this equation. So this one will be the first and this one the second. And rearrange in matrix form or solve it in quadratic form. We'll have 17 here, negative 5, V1 and V2. And we'll have 100 here and 20 down there, negative 5 and 6. Okay, and V1 will be equal to, if I'm not mistaken, this value. And the second unknown variable here, it will be 10.91, I think. Okay, so thank you. Please verify this in your calculator. Okay, bye bye. Thank you.